I've mentioned the term slope of a function in a previous video, but that was easy to understand because our function was linear, so its graph in the coordinate system was a straight line. But how do we interpret the slope of a general function? This is called the derivative, and we will look at it in this video. So let's get started. So let's say we have a function like this. So our question is, how do we interpret the slope, aka how much the graph increase under one unit change of the input x at any point? And this we will interpret as the slope of the tangent line of the function at the question point. So for example, if we have an x0 point here, where we want to calculate the slope of the function, then we would have to draw there the tangent line, something like this. So this will be the tangent line at input x0, and its slope will be the function's slope at x0. But if we take a look at another input value, for example here at x1, then the tangent line will be different than at x0 because of the change of the slope of the tangent line. As our independent value x is changing, we have another function, and this is called the derivative of the function f of x. So the derivative of a function f of x gives us back the slope of the function. And this is denoted by f prime of x. And also we can use this df over dx. And this is logical if you think about this fraction, because this fraction gives us back the function value change over the independent value change, which means how much our function value changes over one unit change of x. But how do we actually express this fraction? And for this, I will zoom into this part of the function where we are calculating our slope of the function, and I will draw here the zoomed area of the function. So here is our tangent line, and let's say here is our input x0. And how I will approximate the slope of the function is the following. I will increase the input independent value by a little number epsilon. So here we will have x0 plus epsilon, and epsilon is much less than 1. And here we will have the output values f of x0, and here the f of x0 plus epsilon. And here we have a right triangle with this yellow one. Here is our right angle, and the slope of the function can be approximated with the tangent of this little angle here, because this will give us back the vertical change of the function over the horizontal change of the function, and these can be written as f of x0 plus epsilon minus f0, f of x0. And here I would like to highlight that it is important for us to subtract the earlier function value from the later one, because this way we will have a negative value in this example, and this is okay because we can see that the slope of the tangent line is negative, and the horizontal change is epsilon simply. So we will want to divide these expressions. So our f prime of x, our derivative function can be written as f of x0 plus epsilon minus f of x0 over epsilon. And in general, this is at input x0, but in general, it can be written as simply f of x plus epsilon minus f of x over epsilon. And this is our derivative of the function f of x. And I will show you a concrete example for which we will use this expression. So let's say we have a function f of x, which is 2x squared minus 3x plus 4, and we wanted to calculate the slope of the function at input x0 equals -1. So what is the slope of the function at this place? So let's get started. Let's use this expression. So f prime of x, the derivative of our function, is this notation, this expression. And for this, first we will use the x plus epsilon in the place of x, and after that we will subtract the f of x itself. So we have 2 times x plus epsilon squared minus 3x plus epsilon. So what we are doing is now calculating this first term, and we will subtract the f of x, which is 2x squared minus 3x plus 4. And we will divide by epsilon. So let's see what this fraction gives us. So let's see, this is equal to, and here you can see that we have a square of sum, so a plus b squared, which is a squared plus 2ab plus b squared. So we will use this identity, so 2 times x squared plus 2x epsilon plus epsilon squared, and I will multiply this, so minus 3x minus 3 epsilon, we have a plus 4 there, and I will multiply by -1, so minus 2x squared. Here we have, watch out that negative times negative is plus, so plus 3x and minus 4, and we divide by epsilon like this. Let's see, so here I will multiply by 2, so 2x squared plus 4x epsilon plus 2 epsilon squared. Here we have a minus 3x minus 3 epsilon plus 4 minus 2x squared plus 3x minus 4, and this is divided by epsilon. And here we will have a lot of cancellations, so 3x eliminate each other, and plus 4 negative 4 here, and 2x squares as well here. So what we will have is 4x epsilon plus 2 epsilon squared minus 3 epsilon, and this is divided by epsilon. And we will do the division, so we can simplify by epsilon. So what we have is 4x plus 2 epsilon minus 3. And since epsilon is much less than 1, So, I don't know, 1 to the power of -5, for example. So this is much less than 1. And because of this, we will only have the 4x minus 3. So the derivative of our function is 4x minus 3. And as I mentioned, this is also a function, and this we can see that it is depending on x. So let's just calculate the slope of the function at -1. So f prime in the place of -1 is 4 times -1 minus 3, which is -4 minus 3, which is -7. So in this video, we learned what is a derivative of a function, and we used its definition for a numerical example. I hope you understood this, and we will meet in the next video.